Okay, we made it to the last section in 10.7, probability. Yay! Woohoo! Over these next 3 days, you are going to learn how to compute empirical probability, compute theoretical probability, find the probability that an event will not occur, find the probability that one event or a second event occurring, and find the probability of one event and a second event occurring. So the first one here was or, the second one was and. I don't know if I read it that way. Okay, so probabilities of an event are expressed as numbers ranging from 0 to 1 or 0% to 100%. The closer the probability is to 1, the more likely it is to occur. The probability that is closer to 0, the less likely it is to occur. Which makes sense. If you have a 100% chance or 99% chance, you know what's going to happen. If you are not have like a 2% chance, you know it's very not likely, very unlikely. So first we have empirical probability. Computing empirical probability, the empirical probability of an event, E denoted by, so P of E is the observed number of times E occurs over the total number of observed occurrences. So this is if I gave you guys a die, and you guys roll it, and I want you guys to find the probability for you guys, the empirical probability of rolling a 3. We know the theoretical probability is 1/6 of the die, but if I told you to roll it 50 times, you'd have 50 different outcomes, and you're going to see how many you had on there. So here, the data in the table is based on 100,000 U.S. women ages 40 to 50 who participated in a mammography screening. Find the probability that a woman aged 40 to 50 has a positive mammogram. So we know the total. That's not the button I wanted to use. Let me see if I can get that to not be that way. I can't. Well, this is fun. Ignore that. Don't look. Okay. So here, we know the total. It's 100,000. And the observed, well, the number that has positive mammograms are here. So it's 700 for the people who actually had breast cancer, and 6,944 for the people who don't have breast cancer that got a positive screening. So we add those two together, and we get 7,664 over 100,000. And when you divide this, you get 0.0764, which is approximately I don't really need that one. It's approximately 7.7% for our probability. So this is the percent of women who have a positive mammogram who participated in the screening. So it does not mean they have breast cancer, just a positive mammogram. So next up, we have the data, again, the same, but now you want to find the probability of a positive mammogram among women with breast cancer. So now, of the group that has breast cancer, how many had a positive mammogram? So we're going to look in this column for our total. So our total is going to be 720 plus 80. And then people that had a positive, well, our positive was and had breast cancer is just at 720. So you have 720 over 800, which gives me 9 over 10, which is 90%. So my probability of with you breast cancer of you testing positive on a mammogram is 90%. 10% have breast cancer but had a negative mammogram. Okay, so now we're on the try it yourselves. So I erased part of it so I could still have this little table. So it says on your first one, part A, use the table to find the probability that a woman 40 to 50 has breast cancer. So the group that has breast cancer is this column here. So that's 720 over plus 80 over our total. Well, we don't have a total column here. So we have to add them all up. So you have 720 plus 80 plus 6,944 plus 92,256. So I know the top's going to be 800 and the bottom's going to be Okay, and the bottom's going to be 720 plus 80 plus 6944 plus 92256, 100,000. So 8 divided by 1,000 is 0.008 or 0.8%. So of the people who participated in the study, the probability that the woman has breast cancer is about 0.8%. Okay, among women without breast cancer, so let me erase this. So B, women without BC, find prob positive mam. So our column now is without breast cancer, and you want to, in this case, a positive mammogram. So we have 6,944, and then the group that doesn't have breast cancer is at 6,944 plus 92,256. So that gives me 6,944 plus 92256. Okay. 6,944 divided by 99,200, which gives me about, let's just double check, 6,944 divided by 99200. Okay, yeah, it gives me about 0.07 or 7%. So women without breast cancer with a positive mammogram, the chances that you do not have breast cancer but had a positive mammogram is 7% in this study. Okay, and then we have a last one. Let me erase what we have. Look at that. There's a whole other group of questions under this from our first one. Let me erase that again. Silly me, I should just done the white erase draw on top. Okay, and then our last one here, C, is among women with positive mammograms. So women with plus mams. Find the probability, find prob of no breast cancer. So, of women with a positive mammogram, so positive mammograms are this direction, find the probability of the women not having breast cancer. So inside the positive mammograms, not having breast cancer are 6,944 over our total 6,944 plus 720. So that's going to give me 6,944 plus 720, 7,664, 6,944. 6,944 divided by 7,664. So that gives me about 0.906. So that's 90.6%. So of women who had a positive mammogram but did not have breast cancer, were 90%. Okay, that's as far as we're going to go today. Try the homework tonight, and then we're going to move on to our next one tomorrow.